Jessica, do you think we should start?
I think we could probably get started maybe at 9:05 or so. I will say that we're having pretty severe thunderstorms and flooding here in the Dallas-Fort Worth area today, and a number of people have emailed me saying they don't have power and won't be able to join this morning. So we might have
we'll
lower
wait.
numbers at least today.
Okay, we'll wait for a couple more minutes and hope. Yeah, since yesterday it has been pretty bad here. We had a lot of hail yesterday.
Yes.
Where I live.
Yeah. Same here.
Shall we? Okay then. Good morning, everyone. I hope all of you had a great long weekend and you're recharged to go through one more week of boot camp. Appreciate you guys joining us this morning. So I'm going to sort of wrap up my portion of the boot camp with the introduction to metadata and provenance. I had also given a evening activity last time we met on Thursday, and we also discussed the multi-source data analysis. I hope some of you had an opportunity to play with the dashboard. And if you have any feedback on that, I would be happy to hear that and see, because we are still continuing the development of these dashboards. So I would like to get whatever you need to say. If your bandwidth allows, please keep your video cameras on. And I see a couple of them that would be useful. So I'll be spending about 45 minutes today talking about metadata and kind of the lineage with respect to metadata. Okay, so let's start with the presentation outline. So basically, we are going to cover, what is metadata, why it is important. So you already have an idea, with the FAIR principles and other things, but this is really the key, and I'm so glad that some disciplines are doing it much better than some other disciplines. And for the long-term usage and analysis of data, this is really important. So what are the implications of not having metadata? What is provenance? Where is it useful? And how does metadata relate to the FAIR principles, which is the main theme and focus of this workshop? So what is metadata? So is it just a question of finding data? So we may argue that, with the Google and other search tools available, why do we have to worry about locating the data? It's so easy, all of us are very familiar with that. But what I want to remind you guys is that data was being collected long before the advent of Google and other things, and it was being used, albeit in a simpler way. And even then, metadata was important, and there were considerations about that. So those tools may help you find some of the data, but finding is different from understanding, figuring out where they came from, and how trustworthy they are separate problems not addressed by search. So that's very important. So search just finds you the data, but nothing more about the data. Also, even with those tools, one may not be able to locate all data because there are a lot of data that is stored beyond the reach of search engines in hidden webs or databases and other places. So one would like to make sure that all the data that is available and is can be made available if that's the case. So hence, what we need is a better uniform mechanism for this purpose, not just a search engine. Search engine is an integral part of that. So here is sort of a exchange from your domain. I think you guys understand it much better than I do. How do I extract metadata from Google Earth? I download the satellite image from Google Earth Pro. The data I want to know is the date, resolution, and the server from which the image was taken, uh, and other information. Therefore, I would like to know which server they. So I would like to know how to get the data for these images. So one of the answers that was posted was the following. Google does not provide metadata for the many images that get combined into satellite view mosaics, but in Google Earth Pro, using a combination of the historical imagery tool, the image date reported in the status bar and the copyright strings, you can usually figure out the date and provider of many images. That said, if the imagery is very high resolution, like the following, then it's probably aerial imagery, which is mosaic from it. So so this is the route one has to take if enough information about the data is not readily available for the user. So without proper metadata, you need to resort to some guesswork and maybe educated guesswork. So the next question is, okay, we are familiar with data, we use data analysis. So what is the difference between data and metadata? So data can be described as what is collected and used for understanding of the data, basic analysis using statistics and other tools, and applying more sophisticated analysis tools like mining, machine learning, and others for deriving the nuggets of knowledge that we are interested in. That's our main goal as we went through previously. Data is also used for visualization and presentation in different ways. So it becomes easy to understandable, not only for the expert, but also for the end users. So for example, we saw this in one of the earlier talks. Using census data, you can obtain demographics information, income average at different levels, density of population. However, given a census data such as this one, so this is one of the data that I use for my data science class. So here, this is how the data is available. So this is a comma separated data, as you can see, and has a number of fields starting from a number and going all the way to something less than or 50K. So how do we use it without additional explanation? If you're just given this one, maybe some fields are understandable, that has, female is understandable, and high school graduate is understandable. But apart from that, it becomes difficult to understand and do the analysis. So as you can see, data by itself is difficult or sometimes impossible to interpret or understand as to what they represent or mean. Not useful for meaningful analysis. Merely providing raw data is almost useless for everyone except the person who generated it, and even if that person can remember it. Given the size, ubiquity, and complexity of data available for use, there must be some way to add additional information to understand, interpret, and use data meaningfully. And simply put, this is the role of metadata. So now you can understand sort of the difference between the data and the metadata. So the metadata is the data about the data, or description and other information about the data, or data that describes other data. So the concept seems to have originated, just going back to, from metadata for library catalogs. So this was say even before the search engines, libraries existed as back as Alexandria. And people had to keep track of information to find things, to make it accessible to people to understand how to locate them. So certainly metadata is useful for humans who will be using the data for analysis or any other purpose. So that's one aspect of the use of metadata. For example, the description of fields for the above census data will help humans understand it. So here is the description of the data. So you can say, work class, which is the second field, which has the following different categorical attributes. The third one is continuous number. So it's something final weight that's described further. Then education level, education number, marital status, occupation, relationship, race, gender, capital gain, capital. So once you have this description, it makes a lot more sense to interpret the data and then figure out what analysis you want to do, and then figure out the tools for that analysis and also for understanding and visualization of the results. So this is typically, the description of the data, but this is not the only thing as part of the metadata, as you will see. So certainly metadata is useful, as we said, for humans who will be understanding and doing analysis. Okay, looks like this is okay. There was something else that I missed. Okay. So what I want to point out is, in addition to humans, the metadata may also need to be understood by a computer or a machine for doing certain analysis. So that's another role that metadata should play. Is in addition to that, I think both are equally important. The human who is going to analyze the data need to understand it. Hopefully the person is a domain expert and can relate to that and figure out various analysis. But at the same time, you don't want to be doing a lot of analysis just manually. So for that, we need to be able to understand this. So metadata is information about data. Similar to a library catalog record, metadata records document the who, what, when, where, and how, and why of data resource. Kind of, these are the important information. Geospatial metadata describes maps, geographic information system files, imagery, and other location-based data. So creation date of the JS data author, contact information, source agency, map projection and coordinate system, scale, error, explanation of symbology and attributes, data dictionary, data. So these are all different things. So this list of things that you want to provide as part of metadata may vary from domain to domain. For example, if you take a biological systems domain, you may have slightly different set of attributes that you want to provide. If you take computer science, it may be slightly different, but all of them sort of lead towards the same thing, understanding by the humans and ability to process by the computer in order to do better analysis. So a lot of structural metadata comes with Gmail. So you may or may not know that. And a lot of this information is generated by the machine, which is rarely seen by the people who receive the email. So here is a sample. So kind of this is the kind of information that you have as part of the headers that comes with every Gmail. If you want, you can go and look at it. And this contains a lot of information. So you can see the volume of information and the actual information is very small in this case. So what does it mean? This gives information about where the mail originated, how it came through different servers, how it was delivered to you, and various other things that are associated with the mail itself. So some of them can be generated by the machine, but a lot of them cannot be generated by the machine because the human has a better understanding of what the data is. So another definition from NIST, which is the Standards Technology Institute, information describing the characteristics of data, including, for example, structural metadata describing data structures, data format, syntax, and semantics, and descriptive metadata describing data content. So we have seen a little bit of that. We'll also see now what are the structural metadata associated with that. So in some sense, metadata are also data. But it's a data of a different type used for a different purpose. There are pieces of information that have some meaning in relation to another piece of information. They can be created, managed, stored, and preserved like it. So this is important to understand. We have discussed data analysis, data storage, data management. So again, metadata storage and metadata management are equally important. And you can do it using the same principle, same technology for doing that. Metadata is also stored in a file, for example, or in a database or wherever it is. But what is important is the association between the data and the metadata, which metadata corresponds to which data, so that you can put these two together to understand things. So metadata can be applied to anything. A computer file can be described in the same way that a book or a piece of art can be described. For example, both can have a title, an author, and a year. Metadata should be documented for research purposes of any kind. Metadata typically has little value on their own, except in a few circumstances. So metadata adds value to other information, but are usually not valuable in themselves. What it means is, if you just isolate and look at the metadata without the data that it is trying to describe, then that may not make a whole lot of sense. So there are exceptions to these rules, such as, whenever we do the video, we get a text transcript, which can be used alone, even though that is metadata. Even though it's metadata, that can be understood in itself. So what are the different types of metadata? We have descriptive metadata, which is very easy to understand, consists of information about the content and context of your data, title, creator, subject, keywords, and description. So abstract is kind of you can think of it as a metadata for a paper. Structural metadata describe the physical structure of compound data. It can be, camera used, aperture, exposure, file format, and relation to other data files. Administrative metadata are information used to manage your data, when and how they were created, who can access them. This is very important. There is a lot of public data, there is a lot of proprietary data. So if you are accessing a proprietary data, you need to know that this is under license and it has to be obeyed. And there may be limited license for academic usage. For example, a lot of data is made available for research purposes, but not for commercial usage. Software required to use them, that's very important. And copyright permissions, what are the copyright permissions? So sort of you can think of, even though there are a large number of attributes and types of metadata that one needs to associate, you may or may not be able to or want to associate all of them with all of them. So there should be some kind of minimum that says the following are recommended as a minimum set of metadata elements. It's important to select a metadata standard or schema. We'll come to that. Appropriate to your discipline, because that's also very important, and our repository, which maintains the data and the metadata, and consult the schema for complete information on each element. You may choose to use more elements based upon the needs of your project, the expectations of your discipline, and our requirements of your repository. So all these are considerations for creating meta. I think in this bootcamp, you will be creating metadata. There is a tutorial on how to create metadata. And at the end of today's module, I'm also going to give you two repositories and compare the availability of metadata in them to get an understanding of why one is better than the other. So title or name, that's important. Description, format, file format, physical medium, metadata, description of the metadata to be provided. Identifier, this is very important because this is useful for searching. Rights holder, rights information, contact information, and others. So complete metadata can be of different types. I will not going into the details of all of this, but you can understand. So we have sort of looked at descriptive metadata, a little bit of administrative, uh, uh, provenance, which is where the data came from, sort of how long it has been preserved. Some of these things are important, even from the trustworthiness point of view, structural metadata and use metadata. So if we understand what is metadata and why it is important to create the metadata along with the data that is used for analysis, we have to also look at the standards and schema that is available, that has been used by the community in different disciplines. So to be useful, metadata needs to be standardized. So standardization is one way we make sure that everyone plays by the same rules. Everyone understands what needs to be done. This includes agreeing on language, spelling, terminology, etc. If no standard is used, it can be very difficult to compare data. So we have gone through the integrity standards and other things in the previous module. A key component of metadata is called schema in the computer literature. So we have schema for a database, for example, exactly for the same reason, because if you don't have a schema, then everyone can design their formats in whatever way they want, and it will become very difficult to understand. So metadata schema outlines the overall structure of the metadata, just like a schema for a relation. It has a very specific standard format in terms of the attributes and the types of information that is associated with that. A metadata schema describes how the metadata is set up and usually addresses standards for common components of metadata like dates, what is the format of the dates, names, and places. There are also discipline-specific schemas used to address special elements specific to needs of a given discipline. So just to give a perspective on how long we have been using and what are the different metadata standards. So perhaps the first one, the earliest one, is what is known as the Dublin Core, and it is used by libraries, can be adapted to other disciplines. Metadata object description schema. This is richer than the Dublin Core. Darwin Core is a metadata standard used by biological specimens, as the name suggests. NASA has a lot of standards. It has a heritage standard before it started using the Earth Science Data System prior to the start of the legacy. Federal Geographic Data Committee, that's very close to your discipline. They have a lot of data standard, metadata standards for specifying them. You'll learn about this for creating this in this, I think later today. So metadata for consumption. What if a non-human or a computer wants to use the metadata and perform some operations or analysis on data based on it? The format that is good for humans may or may not be appropriate for non-humans or a computer. So this is where a very specific grammar and how metadata should be recorded comes into picture. Hence, there is also need for metadata that can be used, consumed by computers. So one of them, which is very widely used, is known as the RDF format. This is the resource description format used for describing various types of things like ontology and others, and it's very widely used. RDF specifies triples, so it has a very rigid format with resources in subject and object fields. They can be URLs, has been used for taxonomy and extensively in semantic web 2.0. So RDF is from the Worldwide Web Committee. Standardization is a standard model for data interchange on the web. So this may not be something you may be using a whole lot, but this is widely used in computer science. Other technologies such as OWL build on RDF and provide language for defining structured web-based ontologies. Search engines can use the information available to make search more focused. RDF can be used to integrate data from multiple sources. So multiple source data integration and analysis and used by search engines can be done using this kind of metadata. So RDF can be used to build label directed graphs, is domain independent, so it can, the content, the values can be from any domain. Can also think of metadata for metadata. I mean, that's like higher order logics. If you're familiar with, there's proportional logic, there is first order logic, there is also second order logic, but just from a theoretical point of view, metadata can be generated manually or through automation. So we saw as part of the Gmail what kind of metadata is generated by automation that is stored somewhere. But typically, manually generated metadata is more useful, but there are situations where metadata is generated. So we are developing, as you know, a bunch of tools. For example, in the database world, creating a query is very important. And if you want to make sure that query is in a format that is understood by many systems, today we use JSON for that. So the tool that is used to create the query automatically spits out either the JSON format or the XML format of the query, which can be sent to any DBMS or processing. So manual creation increases accuracy and can provide better description as compared to automated means, which may generate basic information such as file size, extension, creation date. So Amazon Turk is one of the tools that is available from Amazon. I don't know whether it in computer science this is used a lot. So what Amazon Turk allows one to do is to, pay humans who have experts in a certain to manually annotate or create metadata that is more trustworthy than doing it some other way. So it's a manual task, and essentially you are using crowdsource for generating this one. And in order to do that, you can set certain conditions and other things to qualify people who are doing it. So this is a very widely used technique for various things, including metadata creation. So even though this was originally designed as a data model, or data commonly used for description and exchange of graph data, consists of tuples. So Sparkle is a query language that can be run on top of that. The only downside of this, it has a large footprint. When we say large footprint means the size of the file is large compared to the actual data content that is useful. So while metadata provides unique contextual information about a set of data, it does not, strictly speaking, provide content about the data. So metadata is the description of the content, but not the content itself. Metadata can tell you when a message was sent, but it won't tell you the actual text of the message. Similarly, metadata can tell you where a picture was taken, but it won't let you see the actual picture. Of course, a lot of valuable information can see. Our interest is to use metadata for various purposes, for finding the data, for accessing the data, understanding the data. For our analysis, interoperability and reusability can be made possible with Approx. So this is what sort of ties into the FAIR principles. So metadata is key to make sure the data is uh, stored or made available using FAIR principles. So what are the uses of metadata? It can enable data discovery. We'll see, it has various identifiers that are persistent that can be used by search engines. Of course, you can understand data. You can do analysis and synthesis, maintaining longevity of data. So keeping track of and using it over a period of time, tracking the progress of research project and demonstrating the return on investment. So these are the various uses. So again, I will not go into the details. So examples of metadata records in sort of your domain for different purposes of information, view the metadata record in its native XML code. So I have put links. I don't know, yesterday when I tried to go to one of these links, the server was down. Maybe it's up to date. So for biological data with taxonomy, this link will take you to the XML format. And many times, in order to render XML in the best possible way for human consumption, you need something called a style sheet. So XML is associated with a style sheet, which essentially says, how should we display this content from this XML file? So typically, whenever you have an XML file, you also have the style sheet information that goes with that. That is part of the XML file that is used for rendering it. So here is the standard for geospatial data, tabular, non-spatial data, project level data, system level applications or collections, aerial photography describing this image, water sampling site, database and model. So these are the various standards that are available, used by different groups. Okay, so briefly, a little bit about the data provenance, also termed data lineage. I mean, to me, one easy way to understand is what do you think of ancestry.com, sort of where you came from, what is the lineage, and that is the equivalent of data for the provenance, where it came from, how it is being used. refers to a record trail that accounts for the origin of a piece of data in a document, database, or repository, together with an explanation of how and why it got to the present place. If you look at it carefully, Word documents carry some provenance information in one of their properties as part of its property, including versions and other things, who created the document, who edited it, and so on and so forth. But that's very limited, sometimes referred to as 5Ws: who, why, what, where, and when. Provenance is an important issue for scientific data, where it is central to the. So this is very important. So if you are doing something with, for example, with healthcare data, doing analysis, you need to really know the provenance, where it came from, how trustworthy it is, who collected it, was it done in the right scientific way so that you can rely on the results of analysis. So data traceability lets investigators see how information has evolved or trend, especially today with the digital world. Tracing data or what is happening even on social media for various forensic and other things, data provenance is very important. Where this got generated, how it got generated, what was the impetus for this. Healthcare, very important in many contexts. As I said, USGS data as well. I mean, remember the wrong place that was bombed in Yugoslavia in 1999 because updates were not performed on a database and no one looked at the data provenance, so they had the wrong map. So they just used that map to do something that did not go very well. Traceability and trustworthiness depends upon data provenance. So this is very important. Just to give an example, if you have clinical trial data, you want to know whether it is trustworthy. If the trial is large, it can be replicated, whether it is a randomized trial or not, and whether it was the controlled clinical trial. All of these are extremely important for trusting the results of your analysis. If the data was not generated, I mean, there are hoaxes in scientific literature and history. You might have heard of the missing link. Missing link was one of the hoaxes that were created by scientists for explaining something very cogently, later turned out to be something that was set up to do so. So provenance is very important. We may not realize it in certain contexts. It may not be that important, but in other contexts, it's very critical. So kind of, I'm trying to here sort of relate FAIR principles and how metadata is important to codify some of the FAIR principles. I mean, you're going to learn a lot more about this from people who know about it a lot more than I do. So these are things taken from here. So metadata are assigned a globally unique and persistent identity. So this is very important. So globally unique meaning, there is no duplication of that, and persistent meaning this is not a transient ID. This is there forever. So you know URLs. There's something called ArcID. This is devoid document object identifier, which is given to all documents that are generated and archived. Data are described with rich metadata, intrinsic, automatically generated, and contextual metadata, like the protocol used. Metadata clearly and explicitly include the identifier of the data as they are separate files. So remember, data and metadata may not exist in the same file. Most of the time they do not. Data may contain some very small amounts of metadata. Metadata are registered and indexed in a searchable resource. So that's very important. You should be able to search for that. Regarding accessibility, metadata are retrievable by their identifier using a standardized communication protocol such as HTTP or HTTPS or FTP. The protocol is open, free, and universally implementable. So some of these are non-proprietary. There are also proprietary protocols, so you don't want to be using them because it becomes less accessible. The protocol allows for an authentication and authorization procedure where necessary. So certainly that's very important. So HTTPS and FTPS have authentication mechanisms and this as well. Metadata is accessible even when the data are no longer available. Metadata may have its own value. The effect of FAIR principles, the third component, interoperability. Metadata use a formal, accessible, shared, and broadly applicable language like RDF or JSON or XML. There are so many of them, OWL and DAML. Metadata use vocabulary that follows FAIR principles. That means that vocabulary should be standardized. You cannot just use whatever terminology that comes to your mind. Metadata include qualified references to other metadata, cross-references, dataset dependencies, and finally, reusability. Metadata are richly described with a plurality of accurate and relevant attributes. Metadata are released with a clear and accessible data usage license. This is very important. This can be viewed as a legal interoperability. Metadata are associated with detailed provenance, so that's the lineage, clear story of origin history. Metadata meet domain relevant community standards. So this is also very important. Every community has their own way of describing their data, and the terminology that is used is different. Best practices of specific standards. So metadata is kind of is what how FAIR principles are codified are through metadata. So along with unique and persistent identifiers, metadata is considered the cornerstone of the FAIR principles guiding scientific data management and stewardship. So the challenges that are part of this is how to produce richly described metadata authoring that you will go through and learn more about evaluating digital object fairness levels. So there is something called fair assessment. And there are standards committees that assess whether a particular website, whether a particular repository conforms to the fairness level. Some of this will be discussed. So I just wanted to throw this saying that it is good that this importance to metadata and FAIR principles are given in your domain. In contrast, from the domain I come in, computer science, this is not a priority. This doesn't seem to be a priority, even though it should be. As far as I know, metadata guidelines do not exist the way it is in other disciplines. I'm not sure the reasons are most of the data is using most of our data set search is using Google with keywords and going to known repositories that have collected. So we know data sets can be uploaded or submitted by users, but they don't insist that metadata is also submitted as part of this upload. I think that is the key. If you accept data without metadata, then it becomes very difficult to understand it and use it. They are maintained by universities or other groups. So here is, so when I do a search on the Google asking for CS dataset repositories, you get a bunch of sites that all contain a lot of data sets that are for different purposes. Some of them for mining, some of them for machine learning, some of them for different domains. So, but most of them, as far as I know, do not have very good metadata associated with them. So a CS repository or a repo is a computer storage for maintaining data or software packages. This location contains files, databases, and information. One of the very popular repositories that we use that contains tons of data is the Stanford Snap repository. So here is a kind of description of what these repositories, what kind of metadata, if you will, these repositories contain. You can see that they're very meager. So this is the name of the data set. This is a communication network. So it's a graph, whether it's directed or undirected, number of nodes, number of edges, and description. That's it. That's all you get, nothing more than that. Similarly, if you remember Enron, all the emails that were part of the Enron case was made available for research purposes. We have used that ourselves for some research. So email from Enron is an undirected graph, so many nodes, so many edges, email communication network. Similarly, wiki token. So you can see that the amount of metadata associated with some of these we still use this for our research, for finding substructures, for finding various graph metrics and other things, but we have to spend a lot of time understanding the data and then figuring out how we want to analyze them. So to summarize, efforts in creating metadata using guidelines along with FAIR principles go a long way in the access and meaningful use of. I think that is very important. I think that is the core theme of this workshop, is to make sure that you as budding scientists who are going to be working in this area should clearly understand this and subscribe to this. When the data sets are very large and complex, this becomes even more important. It's important to pay attention to both metadata creation as well as whether they conform to print. So it's not that you create some metadata according to whatever way you think is appropriate, but you need to make sure whether they conform to the FAIR principles and can be useful. You will be learning more about metadata creation and tools for that in the next module. Data provenance is critical for many applications. So as part of the evening activity, what I'm going to suggest is to look at these two different repositories. This is more of the computer science domain. This is from a different domain. Compare the time you need to analyze data sets for your purpose, compare the kind of metadata, amount of metadata, and whether they're in the standardized. Hopefully this will give you an idea of the importance of metadata and FAIR principles you're learning in this course. So with that, I would like to thank you all for attending this and answer any questions and move on to the next module. No question. If not, I didn't check the chat. Okay, there's nothing that I can see. So I'm going to hand it over to Jessica, who will continue with the program.
Thanks, Sharma. Hi, folks. So hopefully you have a good understanding now after Dr. Chakravarthi's description of metadata and provenance and the discussion there. So what we're going to do today is look at different examples of metadata and see what some examples are within our science domains, and then also see how we can actually create these metadata files, because as Dr. Chakrabarthi said, and hopefully you understand now, they are very important for actually not only understanding and using the data, but also adhering to the FAIR data principles. So let me start by sharing my screen. Let's see. Okay, so hopefully you can see this now. And we are going to go through metadata creation. So this is me, of course. So the first thing I actually wanted to do is go through a few different examples of metadata, because they vary widely And as Dr. Chakrabarty said, some domains are better at metadata than others, right? And so we always think of computer scientists as being the best at, data manipulation and whatnot. But when I first talked to Dr. Chakrabarty about metadata, he kind of told me that, hey, computer scientists really don't have a standard for metadata and we're quite bad at it. But as you can imagine, um, as engineers, as civil engineers, as earth scientists, we deal with a lot of spatial and temporal data. And so for us, metadata is extremely important because we need to understand where on the earth our data is actually coming from and what time periods. And we understand so much about how physiographic factors influence our data sets. And then also we understand seasonal influences on our data as well. So for us in particular, sort of in the data sciences type fields, metadata, it can be or is extremely important, and therefore we have developed much better, I would say, description of how, or ideas about how we should convey our metadata. So generally speaking, I would say the most common format for metadata is this XML. I actually can't remember off the top of my head what the X stands for, but it's a type of markup language is what that ML stands for. Um, so this is an XML file that I got.
It's extended markup
Extended.
language.
Thank you. See, look, the data scientists are the computer scientists coming in with the knowledge. Thanks, Dr. Chakrabarty. So yes, extended markup language. This is what it actually looks like. It's a little bit hard maybe to parse right away because it does look very, I don't know if I want to say use the word codey. It looks quite a bit like code, but it is a very well structured language. And then also it's really easy for computers to actually parse this language because everything is tagged with what it is and what its description is. So it's really easy for you to write a code that can help your computer read in this type of information as much as necessary. So this is an example of a LiDAR, of metadata for a LiDAR data set that was developed by the USGS. So I'm not going to show you all of this, but this is just to show you a little bit of how detailed it is, talking about who developed it, the origin, when it was published, what the title of it is, and then, obviously what it is gives the description. And then down here, we have a bunch of information about how the data was collected, where it was collected, what sort of factors were in place when it was collected. We have here about how accurate it is, more information about how it was collected. We have some information down here about the dates and times that it covers. More information about that. Its bounding coordinates. So we're understanding from this where this data is actually coming from physically across the world. We have keywords, so we understand who we increase the searchability of this data set by by providing these keywords and kind of understanding what it might be used for. What are we looking at here? And we also have more information about data quality, which is important so that people understand how accurate this data is and under which conditions it might not be accurate. And I know Dr. Chakravarty just talked to you about provenance, so we have a little bit here about the lineage and the different processing steps that occurred as this data set was developed. So as you can see, looking at this metadata for this LiDAR data, I guess, do you know what LiDAR data is? Oops. Do you know what LiDAR data is before I keep talking about it? Anybody? No? Okay, we have a couple no's. I was trying to find the chat as I was clicking around there. Yeah, a lot of no's. So LiDAR data is a spatial data set that shows the elevation across the Earth's surface. So we have data from communications similar to radar. So it is usually, I guess there's multiple ways it can be collected, and how it's collected influences its accuracy. But sometimes if you want really, really high spatial resolution LiDAR data, so it shows you really well, the elevation of all the different landforms on the Earth, you can collect it with a drone. And they also have some airplane LiDAR systems, and then you also obviously have satellite LiDAR data as well. There's lots of different ways that LiDAR can be collected, but it is essentially a huge spatial map of the elevation of the Earth's surface at any point. So it'll show you, does it use light reflection to extract this data? I think it uses laser beams, which I guess you could argue whether a laser beam is a light or not. In some senses it is. So what was I going to say? I'm getting distracted by the chat. So it just shows you all the peaks and the valleys and, you know, the water bodies, and it also will capture building heights and whatnot of the Earth's surface. So this is a metadata for a LiDAR data set. So as you can see, there's tons of information, very detailed. This was developed by the USGS, so of course they're going to be good about putting this together in a way that is useful for everybody. So this is an XML file. It's, I would say, like I said, quite common, but also I would say relatively easy to develop, in that it's not doesn't take extreme technical nous to use this to develop an XML. You can write this an XML file just using a text editor or an XML editor that's, you know, available on your everyday computer. So this is one way that metadata can be provided. This is a website for a USGS stream gauge here near the Dallas-Fort Worth area for the East Fork of the Trinity River. That's our primary river going through the Dallas-Fort Worth area. And so here you have metadata kind of broken up in a few different places on this website. I guess first we can look at downloading data. So if you actually try to download the data, you have a little bit of information, metadata here, talking about what the columns mean and what their units are, and also what the data tags are to show for data quality. So you can see that all this data here is marked with a P and it's provisional. I don't think there's anything at the bottom. So we have a little bit of information here. It shows you what gauge it's for, what the name of that gauge is, and so on and so forth, and when this was retrieved and who you might need to contact for support. You can also get some information specifically about this location, which is going to tell you all of the different possible columns, data columns that you get and what they mean. And then also gives you a little bit of information here about which USGS gauge you're looking at. This is down at the bottom. Its code and its coordinates and whatnot, what reference systems it's using. This is NAD 27 and NAD 83, and where it's located at, and so on and so forth. So this is also that this is another USGS source that they provide some metadata. And then if you scroll all the way down to the bottom, you can look at a sample of, or a summary of sample data. So you can kind of see what the data is actually looks like, what's available for it, when it's available, a summary of all available data that they have. So this is all the parameters they have and what dates they're available. And then last but not least, we actually have the word metadata, location metadata here. And this is telling you everything you could, that you would likely need to know. I should almost say everything you will need to know, but everything you would likely need to know about the actual gauge itself. And so this is all the latitudes and longitudes, you know, which district it's in, the state, the county, its latitude, or the altitude, sorry, how the altitude was determined, different flags for instruments at the site. So this means this is if you were to know all those codes, it would be able to tell you which instruments are available for actually recording data at this location. Drainage area for the site. And so there's all sorts of metadata provided also in this way. Again, this is all just data about the data that helps you understand when and where it can be used. So these are both USGS sites, but I also, or USGS metadatas. I also have, okay, there's a bar here. Let's see if I can just do this. I can open it. No, it's still not letting me. Here we go. Okay, so this is from the NASA Earth data. This is one of their data repositories. This is just a precipitation data set that I Googled, and I thought we could look at how they show metadata here because it is different. But it shows you here a little summary of how the data, or what the data is and what's available, its spatial coverage, temporal coverage, how big it is. In case you're downloading a lot, you can plan for how much storage you need. It tells you how to cite the data, which is always helpful. Then we don't have to try to figure that out. And here's the documentation, which we'll take a look at this in just a moment. But here we have the data calendar, which shows you for all the years that the data is available, when the data is available and when it's missing. So the documentation, README. README is always a good idea to take a look at first. I need to figure out how to make this bar at the top go away because it's getting in my way today. All right, let's take a look at the README. Okay, so this is a PDF. So NASA writes these really, really thorough documents, usually publishes them in PDFs on their websites to provide the metadata. So this is telling you, the README in particular, is going to tell you all about how the data is organized, how the files are named, which is really helpful, especially if you're trying to automate download of your data. You don't want to have to go through and click all of your data. You want to be able, in order to download it, you want to be able to write a program that will grab all of the dates that you need, where maybe you're just changing the date code in the URL for downloading or something like that. So file naming conventions can be really helpful to know. It tells you, the file metadata, geolocations, dimensions, products, parameters, and it tells you also something that's very useful, some command line utilities. So this is going to tell you how you can interact with this data through codes, and it gives you some sample codes down here that you can use to access different elements of the data that you can use to increase or improve your workflow. So the README here is very well detailed and very helpful. So let's take a look at this. Is the algorithm theoretical basis document. That's the formal word for it, but I usually think of it as just the technical reference for this data set. This is going to tell you all about how the data was collected, how it was processed, what satellite collected this data, and what assumptions came into play in actually processing this data. And so this is going to tell you everything you need to know about basically the provenance, where it came from, how it was processed, and what you need to be aware of if you're going to choose to use this for your own research. So this is a 33-page document, so very thorough. And this all is essentially metadata for this NASA precipitation data set here. Okay, so these are 3 examples of metadata produced by a couple different federal agencies for data sets that you may or may not need to use. And this is just one example from NASA. There's obviously thousands of these types of metadata documents, PDFs, that NASA has produced. Okay, questions on these 3 examples? No? Okay. So let's carry on. So when you're actually going about creating your metadata, there's many, it's kind of a long process, and it takes a lot of time and a lot of effort, but definitely worth it. So the first thing that you need to do is gather all of your data for the metadata record. And that requires looking at what you actually want to put into your metadata, because what's appropriate for the metadata for your data set might not be uniformly appropriate for all metadata. The metadata that you want to include is going to be dependent upon what type of data you're looking at, who collected that data, who owns that data. You might need to think about, is this my data that I'm freely able to publish? Does my principal investigator, my advisor, own this data? Did a private entity pay for us to collect this data and therefore they own it? And all of these kinds of things are going to come into play about what I am actually able to put in the metadata and to publish through the metadata and through publishing the data itself. There's a lot of options for how you can build your metadata and create your metadata. There's some metadata worksheets out there, metadata wizards and whatnot that we'll go through, but a couple examples provided here are provided by Amazon AWS, and they have some worksheets basically to help you build these metadatas. Or, as I said, there's some tools that we can use as well. So I know Dr. Chakravarthy already mentioned this a little bit, but there's different standards for creating metadata, and one that's pretty popular is the Content Standard for Digital Geospatial Metadata. Again, this is primarily for geospatial data because it is so important for us to understand the geospatial factors that are accompanying our metadata, are accompanying our data, to understand when and where it can be used. And then a much more general metadata standard is the International Organization for Standardization Series of Standards for Metadata, or ISO. And so nobody wants to go through and read all of, I shouldn't say nobody, few people want to go through and read all of these standards and make sure that your metadata aligns to this. So thankfully, they are there's tools associated that will help you build these build metadata that is compliant with these standards, depending on which is more appropriate for your field. And as there's a note down here at the bottom, it says that both of these require metadata to be formatted in XML, or extensible markup language. Okay, so tools for creating metadata records. One of the most popular ones is provided by the USGS. There's a USGS metadata wizard that can be used in ArcGIS applications. It's a Python toolbox, so it is proprietary. You have to have access to ArcGIS and able to use in order to use this. So they also created this USGS metadata wizard 2.0, whatever version you're talking about. And this is just a downloadable desktop version of that metadata wizard, so it's not proprietary. Anyone can access it. You don't need to use ArcGIS in order to do this. And the good thing about these tools is they create metadata that is compliant with the standards listed here. Okay, so other tools that we have. Another option is the USGS TKME, which is another Windows platform tool for creating standards compliant metadata. And this one is more closely aligned with the metadata standards from the biology community. So if you're specifically working with biological data, that might be more appropriate for you. There is the MD editor, which also creates ISO and FGDC CSDGM compliant metadata. And this is a web-based tool, so it's not something you would have to download yourself. You could interact with it right through the web browser. There's the data dictionary conversion service, which creates, will take your data dictionary with metadata about your tool or your data and convert it into metadata compliant standards, metadata compliant with standards. USDA MetaVist, so this is the US DA's metadata tool, and it is another desktop metadata editor for, again, creating standard compliant metadata. And then probably the most basic is just the Microsoft XML Notepad, which is a pretty simple but intuitive user interface for editing XML files. So this would produce, when you're editing it, it would look very similar to, oh, I closed it, never mind, to the XML file that we looked at. So it's maybe, I don't know if I want to say the easiest. It's not the easiest to use, but it is the most flexible to use, and anybody can use it under any situation. So it's a great tool to have if none of these other tools are going to work for you. Okay, so the thing I want to do now is to break us up into breakout rooms to have a little bit of a discussion about which metadata standard and metadata tool would be most appropriate for your summer research project if you have one, or if you're planning one, or you're hoping to do one, and why, what factors go into that decision about which would be most appropriate, and then also what challenges might you face in creating metadata for your research data sets, and how can you plan for these challenges. So I don't know if I've never actually done breakout rooms in Teams before, so this is going to be a new experience for all of us. But I will keep sharing this, and then hopefully you can see this while you are in the breakout room. But I also recommend just screenshotting these discussion questions so you have them available to you. And I guess I can also drop them in the chat so you can have them, hopefully be able to access them that way. So without further ado, let's create the breakout rooms and go to your breakout rooms and discuss these. It's creating breakout rooms. While it's creating them, does anybody have any questions?
I didn't get an option to join a breakout room.
Okay, let's see if I can move you to one. Oh, it says you can't access breakout rooms. That's unusual. Are you using like the Teams online app or something?
Yes, I have it downloaded on my MacBook.
Okay, so you're using Teams on your MacBooks, but it is the Teams like program and not Teams browser version.
No, it's the program.
Okay, strange. I'm sorry. I don't know what I can do. Um, do you want to talk about these with me? We have a couple people in this room now. We can be
Okay.
our own private room, our separate room. Laura and Pranesha, are you there as well? Yeah. Looks like Laura is in room 2. All right. So Chantal, can you say your name for me? Make sure I'm saying it right.
Chantal?
Chantal, okay. Um, do you have any summer research planned?
I don't.
Okay. What kind of research are you interested in?
I don't know. I'm interested in like a lot of areas. I would say like water management would be one, or like
Okay.
hydrology. I also think just like conservation, but I'm not like sure on like to what specific application.
Mm-hmm. Okay. So conservation type work. So if you're talking about conservation work, it's definitely, um, very spatially relevant, right?
Hmm.
Um, I would say time probably as well, because you would be probably tracking different measures over time to see if they're improving or not improving, especially if you're talking about maybe like population counts of both vegetation or animal populations. So you probably would have a variety of data sets in that type, where you're looking at potentially time series counts,
Mhm.
how things are changing over time, but then you might also have, depending on what exactly you're doing, like a grid of data, where each quadrant in the grid is going to have a different, or not quadrant, but each I guess quadrant, each box in the grid is going to have a different value, maybe to see how the impact is changing over time or whatnot. So we're talking definitely about, spatial and temporal data, in that sense, which then, um, I guess based on what we said in class, what do you think would be the most appropriate?
Um, I wouldn't really be sure.
Yeah. I would guess that the USGS uh, metadata standards would probably be quite appropriate, because the USGS, do you know what the USGS is?
Yes.
Yeah, okay. They, deal with a lot of the type of data that you're interested in, especially if you're also talking about hydrology data. They're pretty much responsible for all of the stream gauges, in the whole country, at least that are owned by the federal government.
Mhm.
And so I think that they would definitely be a good choice.
Okay.
Go ahead.
I just had a question for the research project.
Hmm.
Would we like be able to get data sets like from like kind of anywhere, or would we be like restricted to certain like organizations like
No,
the
you can
USGS?
data whatever data set interests you, you can
Okay.
absolutely work with. If you're thinking about sticking with the program over the summer to do some research, absolutely.
Okay.
Yeah.
And the topic is not like restrictive either. It's just like a
No,
personal.
the
Okay.
the whole point for us is, at least for you, to us to help you and kind of nurture you in the data science learning, with whatever data set you're interested in, right? So it can be, we're more interested in your ability to practice what we're teaching you, basically.
Okay.
Yeah. So anything that's of interest, and there's tons of free data sets available online. So you can find your own, obviously, or we could help you narrow down a good option for you if that would work better.
Okay.
Okay, so what challenges might you face in creating metadata for your research data sets? And how can you plan for these challenges? So just imagine whatever data set you're thinking about for the summer. What sort of difficulties might you come across with creating metadata?
I think it'll just be kind of just like the learning curve, because
Hmm.
like I don't like have like basically like any experience. So I think just like getting over that would be like the main, or like the first hurdle I would experience.
Right. Yeah, that makes sense. So I guess that leads us into a good spot for the second part of this question, is how can you plan for overcoming that?
Well, over the weekend, I guess like just watching videos. I forgot which instructor that it was.
Hmm.
But he just gave like some examples of some videos online,
Hmm.
like going over Python. So I guess I would be able to like find the same for creating metadata.
Hmm. Yeah, absolutely. Um, and also, I think talking to people in your field, whether it be your professors or if you have a research advisor or a mentor at the time at your university who um, might be able to provide some guidance on this.
Mhm.
And one thing about the kind of the fair data principles and metadata is, it's not something that everyone is aware of and everyone does well, to be quite honest, in the research field, because it's something that we're understanding is important, and so we're trying to train people more to do it. And one of the exciting things or the interesting things about this program overall is that, you know, you are all here and we're talking to you about these things, but you can also bring these things back to your back to your research advisors, to your professors, and, you know, kind of spread the knowledge that way, right? So you can be bringing these ideas back home to your own research groups or professors or universities or something like that. So it can be a little bit of a way to spread knowledge. But,
Right.
yeah. So I see we have a couple people that have joined us since I made the breakout room. So I will send you to rooms. So the folks that were assigned to a breakout room and are back here with me, did no one else show up in the groups or no one had anything to say in the groups or something? I'm talking to Laura and Pranesha in Yuze. Or this is Jason, right? Jason and Sydney.
It did. And said it was being recalled on way to me.
Okay. I'm sorry, Laura, I couldn't actually hear what you were saying. It was breaking up too much. But
Yeah, people just left from my breakout room.
okay. Okay. So I'm going to, I think, I should have told you guys how long you're going to have before I sent you to the rooms. But I will say, can you still access the main chat in the breakout room?
I don't think so.
No? Okay. I've used Zoom breakout rooms, but never never Teams. Were you in college when we were all online during COVID, or not quite yet?
Whenever COVID started, I was in high school.
High school? Okay. What type of online learning worked best for you?
Like, what do you mean by what type?
Like what strategy of online learning worked best for you, I guess?
Strategy, like,
Like, did you like discussion groups or did you like doing reading on your own, or just doing exercises on your own, or what did the your teachers do that you enjoyed the best in terms of ways to learn?
For online learning, I'd say just do readings on my own.
Okay.
Sometimes breakout rooms kind of awkward, I guess.
Yes, absolutely. I can understand that. Yeah. We try to do the breakout rooms to encourage you to chat and meet other people in the boot camp. But yeah, there is a little bit that awkward, especially if there's no one who kind of takes the lead, if that makes sense.
Yeah.
Yeah. All right. Hi, folks. Hi, folks. Welcome back. Hopefully you were all able to have a fruitful discussion in your breakout rooms. Let's take a few minutes to debrief from what was discussed in the breakout rooms. So we're not going to do this in any formal way. I'm just going to ask for volunteers. So what did you talk about in your breakout rooms? What sort of challenges were identified? What sort of unique data sets are you going to be dealing with that might need some might require some special considerations with your metadata? Don't everybody talk at once.
One consideration that I have to consider is that for my research, I'm doing research in transportation engineering under civil engineering, is that I'm both using somebody else's model and also producing enough data that it would probably require some form of computer analysis. So those are things I need to consider. First, that I don't own the model I'm working with, so I may not necessarily have a choice in terms of type of metadata, but also in that it has to be something that is more. It should be in a standard that puts computers first, because the amount of analysis required for the data would probably require a great deal of um, computer assistance. So those were the two largest considerations that I had.
Okay. Thanks for sharing, Henry. And you brought up a really good point, which we'll cover a little bit in the data usage um, lecture session that we do next. And that's the idea that if you're using someone else's tools or using someone else's models to process your data, that information absolutely needs to go into the provenance portion of your metadata to say, hey, we use this data or this model to manipulate the data in this way, right? So that people understand that resource was used, but then also um, you'll need to look at the usage license for the model or for the tool that you're using to understand how they're restricting or limiting, if at all, the use and the publication of derivative products, basically, right? So if you use their model and they have a really restrictive usage license that they don't want you to publish your data based on that, without their permission or something like that, you know, that'll definitely need to be a consideration, or maybe they have an open data license that you can do whatever you want with it as long as you cite them, maybe, or something. So that's definitely a consideration when you're thinking about developing and publishing your metadata. Any other ideas out there?
There's something in chat.
Oh, here we go. So thank you, Nikhil. It says a couple of us aren't yet sure what we'll be researching, but we'll probably be using Dublin Core or RDF. However, I'm a little concerned about having insufficient metadata and or having trouble combining my data with others into single metadata. Yeah, that's a definitely a good consideration. If you're worried about having insufficient metadata, that might require you to make some phone calls, write some emails to get that metadata that's missing from maybe organizations who helped collect the data or who worked with the data a little bit, or other folks to understand what processing went on as that data set was analyzed and came to your desk, basically. And if you don't have the metadata for something, I would say it's even always a good idea to say, you know, hey, we understand that this data was collected by so and so, but we weren't able to make contact to understand, you know, the conditions under which this data was collected or something like that. That would also be possible because there's the chance that that person had left the organization or whatnot, and that information is essentially, you know, missing. But it's always better to say that than to ignore it, basically, right? And then if you are working with a large team and trying to create metadata in order to publish your data set, then I think that it's definitely would be a good idea to set up meetings focused or specifically around the metadata to bring everyone together and to talk about, you know, who's going to do what to help make sure the metadata is developed well and developed thoroughly. So, yeah. So we have another comment from Michael where it says, while I don't do research in my current job, we're constantly trying to find out when FEMA/USGS models were constructed or by who. Yes, that's an endless struggle. It's very time consuming to find which data set is the most current, so being able to access the metadata is crucial. I'll try to apply this to that. Yes, that's a wonderful observation, and it's great when you actually see the importance of metadata in your own work, right? So if you get frustrated by not being able to find that information easily, as you know has been the case many times in the past, you'll appreciate even more. Someone muted me. How important it can be to develop good metadata so you're not causing those problems for other people, right? You appreciate metadata more when you don't have good metadata for a data set you want to use. Yeah. All right, so I think in the interest of time, let's move on. We are definitely behind, but I hope that you know, you enjoyed being in the breakout rooms and getting to have a little bit more of an organic conversation with some of the other folks participating in the boot camp. Okay, so let's see. Oops. All right, moving on. We're going to take a look at the USGS metadata wizard just because it is such a well-developed tool, and the USGS, at least in terms of US agencies, is really on the forefront of metadata in the US. And so we're going to take a look at that. And it's basically a graphical user interface that you fill in a bunch of boxes, and then it will generate the XML file for you. So it really helps you create that metadata. And so there's many elements of this, but it has different tabs on it that cover identification of the data set, data quality, any spatial information about the data set, the entities and the attributes responsible for it, how you can distribute the data, and then also the metadata reference. So this is what it looks like, but I have it open also. We can just pull it up and take a look. So this is the USGS metadata wizard. Its icon is a duck, which I find a little bit funny. You might not be able to see that well in the screen, but this is the identification page where you can fill in all the citation information, any data access constraints, use constraints, the person you can contact for more information about it, any credit you want to provide for the data set, abstract, purpose, keywords. So you can see it's a very thorough identification information. And then what's also kind of cool here is we talked about controlled vocabularies as being an element of the FAIR data principles and how we can make sure that our language that we're using in our metadata is from our domain. You can actually access the controlled vocabularies for your domain through the metadata wizard, which is very helpful. Data quality, it provides an opportunity for you to share any information you have on accuracy of your data and any errors that might be in place. Spatial information about your data, the bounding coordinates of it, any information about the data content, organization, units, and values, which are always important. You need to know what the name of your fields are and then what the units are. Otherwise, how do you know you're doing the correct analysis? Are we talking about US units? Are we talking about our SI units? And it's not always consistent, across federal agencies. So information about how it can be distributed or accessed, and then also providing which standard you're following for your metadata creation, and then also information on who created the metadata so that it can be provided and people can contact the person who created the metadata if there are any questions or things that are unclear. So this is just one example of the metadata wizards that are out there. I would assume that they're fairly similar, but depending on which domain you're looking at, might be more or less relevant for your domain. Okay, so if you want, I can drop this link in the chat and you can take a look at the metadata wizard yourself. You can download it for free. It's available on a GitHub page, which I have open here, right here. So this is the page for downloading the USGS metadata wizard, if that's of interest to you, and they have links down here for installing it on Windows or Mac or Linux, if you want to do that. So we have we're a little bit over time, but we have a little bit of time because we were actually planning to end early today. So take a look at the US metadata wizard, and I want you, we're going to end this in breakout rooms once again, to just take, we'll say like 5 to 8 minutes to talk about how each metadata component is essential to achieving a FAIR data set. And when I say metadata component, I'm talking about these different elements that are actually included in your metadata. And so how do all of these things help improve the findability, the accessibility, the interoperability, and the reusability of your data sets? We're trying to tie this back to day one. Any questions before we move on? No. Okay, so I'm going to send you to your breakout rooms once more, and we'll come back at like 10:47, we'll say. Nicole, were you able to access your breakout room? So we have a few people here in the main meeting, so we can have a chat ourselves about the question. I'm sorry, Chantal, for using breakout rooms when you're not able to access it.
It's okay.
Yeah. I try things and they don't always work, but that's okay. I appreciate your willingness to be flexible. So thinking about, I guess I can pull up the metadata wizard so you can actually see it and maybe remember. But how or why is each metadata component essential to achieving a fair data set? So you can think about that. And James as well, feel free to chime in. But also, what element of the metadata maybe do you think is the most unusual that you would expect to be important for metadata, or anything like that? I would also be interested to hear.
Well, I would say like an important element for the metadata would be the keywords, just in order so it's findable.
Absolutely. Yeah, those are probably one of the most important, designing good keywords, especially if you're hoping others will be able to find your data set um, from like a repository or something.
Especially, I guess, since like the title may not be like the best reflection of all the data that it holds.
Absolutely. That's one thing that a lot of the students that I work with, I see that they, it's the easy thing to do is pick keywords that are already in your title. But those are actually the worst keywords to pick, right? Because your title is already going to be searchable, right? So everything you include in your title is going to come through in data, like database searches, right? But if you add keywords where it's not listed, it's a concept that's not in your title, but is present in your work, or you think people that would be interested in this keyword would also be interested in your work. You can include that as a keyword to help them find your work, even though it might not be what they were initially looking for. If that makes sense.
It
Right.
does.
So if you're talking about conservation work, it's going to be hard for me to come up with a thought on off the top of my head, but like maybe you have a data set on so when you say conservation, what type of conservation are you most interested in? Because I keep
Um,
using, oh, go ahead.
I would think just more like a focus on like biodiversity levels, kind
Okay.
of.
Yeah. Okay. So like maybe you have collected bird species across, this one forested area, and you have this data set, you're going to publish it. But maybe there, as a keyword, you could put like either a word or a species that cohabitates with the birds a lot, maybe in that specific region. So maybe people who are looking at that species would also find value in your bird species, because maybe if um, you have a lot of this type of bird, it might mean that there's tends to be also a lot of this other type of species that cohabitates with them a lot. Or for example, or maybe if your study is in this one small forested area, but that forested area is part of a larger network of forests, and people who are interested in that larger network of forests might be interested in your smaller area. You could put in your keywords the name for the larger forested area so that people looking at that might find your data set as well. Those are just
Right.
two ideas. Yeah. that came to mind of why you might want to think about your keywords in a different way than just, oh, this is a precipitation data set, so I'm going to put precipitation in my keywords, even though it's already in my title. Yeah. Oh, I said I would bring them back at 10:47. So all right, so it looks like maybe not everyone has come back from the breakout rooms, but maybe they left. That's fine. So let's take a couple minutes to talk about this question. So why or how is each metadata component essential to achieving a fair data set? And in talking about this, we can think about which ones you thought were perhaps the most important for achieving fairness. What did you talk about in your breakout groups? So it looks like some folks maybe were a little slow coming back from the breakout room. So my question was that we're going to start to debrief from the breakout room before we go to our break. And I just want to know what you guys talked about in the breakout rooms and how or why each different metadata component is important for contributing to the fairness of the data set or of a data set. I'd also be interested in any thoughts or comments you made on which element of the metadata you think is most important for achieving fairness.
Hello. So my group
Hello.
members and I were talking about that whenever we do research or just for small projects, that the hardest part is always finding the data. So for us, it feels like the F and fair was the biggest requirement for us. And that having the keywords within the metadata made it easier to find.
Okay, that's an excellent idea, and also aligns well with the conversation I had in my own mini breakout room as well, that keywords can be extremely important for increasing the findability, and well-designed keywords can really help draw people to your data set that maybe didn't realize it was exactly what they were looking for, exactly what they wanted. And we talked about the keywords in my breakout room, that it's really important to select keywords that are actually not in your title, that it's really easy to pick keywords that are in your title, but you're actually being redundant and not adding, value to your keywords if you just use words that are also found in your title. So with your keywords, you usually want to pick words that are important and related to your research data set that don't show up in the title. Things that are maybe really closely related, or very important, but I would say like important in your field, but are maybe somewhat minor, or minor concepts in your data set as well, but that would be of interest to others in your field. And the example that we talked about was thinking about, if you're doing research in a small area, maybe you can add as a keyword the larger region that area is in, to kind of provide people who are looking at that larger region maybe a really detailed data set for a smaller area that might add value to their work that they're doing, or insights that they're doing for the entire larger area. Or for example, if you're talking about a biological data set and you're talking about one type of specimen, but there are other specimens that cohabitate with that specimen or interact with that specimen a lot, you could maybe add that as another keyword, because maybe information about the one specimen could provide insights into the other. We have a comment in the chat from Christina where it says, for the USGS metadata wizard, we talked about how the identification and data quality features respectively represent findable and reusable. Absolutely. We also talked about how the metadata should be able to be read by the computer, accessible. Yes. And that's part of why one of the most common formats for metadata is that XML markup language. And so that the computer can easily parse it, if you're able to write a bit of code to do that. Okay, so thank you so much for sharing on this. I know we're running a little bit behind today, which I feel like is maybe a trend with this boot camp, but let's take a 15-minute break and be back here at 11:10, and we'll carry on with the data usage licensing. Thanks, folks. All right. Hi, folks. Hopefully most of you are back from the break. Let's carry on with data usage licensing. I had asked you, hopefully you saw, through Slack to watch a couple of videos. This is mostly because it can be quite boring for me to just prattle on about all these different types of licensing systems that are out there, because every licensing system has its use and is important for different reasons and is more commonly used by different groups in different domains and whatnot. So there's tons of options out there, and there are more popular options. So I was hoping that by watching those videos, you can understand a little bit more about why data usage licensing is important, what it does, and then also what are some of the different options out there for you to consider when you are licensing your data that you want to publish. So today we're going to we'll do a little bit of review about talking about why data usage licensing are important, and then also talk about the similarities and differences between different data licenses. So just a little bit of background. It's important to, and there are it's important to publish your data so that people can have access to it. That's really important as part of the findable, accessible, interoperable, reusability principles. But I just want to make the point that there are sometimes reasons why data should not be published and should not be openly and freely available to all individuals. There's a lot of rules, at least in the US, around personal privacy and making sure that any identifiable data from your data sets, or personally identifiable information from data sets, is not included in open access, to make sure that you know, that type of information isn't used for nefarious purposes. And then also some domains can't even, such as like nuclear energy or nuclear engineering, oftentimes their data sets are limited access for national security reasons, and they also, when they publish their research articles, they don't even publish them in journals that you or I know about. Basically, they're you know, only for the nuclear engineering industry and for the federal government, basically. So they're very limited access in a lot of cases, and there's good reasons for that, right? National security, and then the last one that's listed here is competitiveness. If you're developing a proprietary project or product that you intend to commercialize, you don't want to share it openly and then let, you know, Joe from down the street, you know, commercialize your idea before you because he found it, you know, through a repository or something. So there's reasons for limiting data access. But if your data doesn't fall under any of these types of umbrellas, and is like streamflow data or precipitation data or land use data or something like this, you know, there might be a good reason for making it open so that we can align to the fair data principles, but then also share the knowledge that we've created and the ability to create new knowledge from our data sets. So any data that you produce is available only at the discretion of the data owner. So as the data creator, as the producer, you have the ability to assign any data license that you think is appropriate, that you want to your data. You have that that ability to do that. And if you want to share information about your data, but you don't want to share your data itself, and you want to provide an opportunity for people to know what your data is, but not to access it, you can publish your metadata on an open repository, and then include in that metadata some information about how they can gain access to that data, if they are approved, if you deem them appropriate. So that is also okay. That's like considered a closed data set, but has all of the metadata openly available so that an individual can find it and they can understand through that metadata how they can access it. And also, hopefully that metadata has enough information in it so they can understand, hey, yes, this is something I want to pursue. This data set is what I'm looking for. And so they understand whether it's of value to them to actually pursue gaining access to it. And so that, is in line with the idea that the Fair Data Principles want us to provide clarity and transparency around the accessibility and the reusability of our data. Okay, so hopefully you have a good understanding of what a data license is at this point, but it is a legal arrangement between the creator of the data and the end user specifying what users can do with the data. And there's tons of different sort of restrictions that can be placed on a data set by the user, or not by the user, sorry, by the creator, to help convey to the user what they're able to do with it. So for example, these are 3 different data pages which show, I guess these all have the same. These all have the same license. So this is 3 different examples all showing the same data license. So this is the Creative Commons Attribution 4.0 license, or CC BY 4.0 license. So this Creative Commons Attribution license just means it's basically a license that says it can be freely used. You just have to tell everybody that you got it from me, that you got this data from me. So you have to cite this data set as part of your free use of it. So lots of reasons. There are lots of reasons for why you should apply a license to your data. Just because it lets people know how they can use it and under which conditions they can use it. So it allows them to share, allows them to be reused, or allows your data set to be reused. And it also provides some legal backing to not only your decision to release that data, but also to other people's decision to use your data. So if you release it under a CC Creative Commons attribution license, and then you find a work that didn't cite your data set that used it, you have some legal backing to say, hey, you didn't follow the data license I applied to this. I want you to provide attribution for that. Or also, if somebody uses a data set, if you find a data set freely available, that's like a data commons license that doesn't require attribution or anything like that, you can use it freely, and then no one can come back to you and say, hey, you owe me $1,000 for using this data that I published, right? Because they indicated that it could be freely used. So your data usage license reduces uncertainty, reduces ambiguity, and it lets users know how it can be used, whether that's redistributing the data, reusing the data, mining the data, combining the data, processing the data, any or even commercializing the data, any type of activity that would be related to the data, your license will tell them whether or not they are allowed to do that. Okay, so that was just a brief refresher, but we're going to, I think this is possibly the last breakout room for the day. I might be forgetting another one, but let's do another breakout room to talk about the pros and cons of data licensing. And I wrote down, that's the main discussion question, but I wrote down a few other questions below that you can think about when you're having this discussion, which is how can we encourage fair data practices while also protecting creator rights? This is trying to think about, if everything is created and it's freely shared, what is the value of going through the effort of actually creating that data? How or why might data usage licensing prevent researchers from generating impactful findings? So if we're limiting access to our data too much, like how much is that inhibiting science as opposed to encouraging it? And how can you share your research results if the research is based on data with a restrictive license or proprietary? So for example, proprietary information, or maybe your advisor doesn't want it shared for some reason or another. So what are some ways that you can share your results even under those situations? So let's once again create breakout rooms. We'll go back with the same breakout rooms for today, and I will open them, and I'll post these questions in the chat as well, but we'll come back at, let's say, we'll do 7 minutes, so about 11:27, 11:28. Pooja. I'm not sure what group you were in, but I just reassigned you to group 2 because you showed up on my list as unassigned. Hi, Chantal.
Hi.
How's it going?
It's good.
It's good. Me get sick of talking to me today. So what are your thoughts on the pros and cons of data usage licensing, or any of
Well, I
these
would say
questions?
the pros would be to give like a clear understanding to like
Mhm.
assist, or like to not only like protect like the actual creator of the data, but also just like the person that uses it to make their job of like accessing the data easier, so they don't have to go to like further lengths of like directly contacting the person if it's like clearly stated on the metadata.
Mhm. Yeah, absolutely. That's one of the biggest pros. Is I think it's important to remember that part of the fair data principles isn't always, freely share everything, but we just want to make sure that we're telling people, how they can access it, how they can use it. So that information is out there instead of just hiding it away, if you will.
Right, and I would say like the main one would be kind of like one of the following questions would be like it would limit like the use of it too much,
Mm-hmm.
or like other like people on like different I can't think of the word but like different projects, they wouldn't be able to
Mm-hmm.
take like the same application even if it would like assist their information or like their purpose of the project.
Mm-hmm. Yeah. There definitely could be an issue, if a researcher knows they're supposed to share their data but doesn't actually want to share it. They could put a very restrictive data usage license on it that would essentially use it or make it unusable for most purposes,
Yeah.
which I don't know if I have a good answer about how we could get around that, because it's a little bit of a cultural thing, I would imagine. How you're socialized as a scientist probably influences how you know, behave within the community.
Hmm.
Yeah.
So then like for the last question, would there just be like no like real option then because of the restrictive license? Like legally, I'd say.
So that's a good question. If the research is based on data with a restrictive license, so in some cases there's no options, right? So if it's like a national security issue and the federal government like mandates that,
Hmm.
yeah, there's going to be very, very little to no recourse. You just, but it's something that, at least in the case when you're talking about, for example, nuclear engineering, it's something that's very well understood within the nuclear engineering community, and also, among scientists that interact with that community, right? So um, they kind of understand that there is that information there, but we don't know it. And if you don't have access to it, there's a reason for that, I guess. And there's always channels for gaining access, right? You might have to go through a security clearance or be vetted in some way, shape, or form to gain access to that data. So it is there, and if you might just need some sort of security clearance for for actually accessing that. But in terms of sharing your research results, it's something that's very much kind of hidden behind a wall. However, so that's if we're talking about like national security issues, right? But like if you have a restrictive license, there's some things that you can do. Like for example, I currently have a contract where my research data is owned by this private research foundation, but I can share the information as long as I get their permission before I do so. So if I want to publish the data, I basically have to share it with them and get their approval before I do so. If I want to publish any papers or go to any conferences and present, I have to basically share my slides with them, share my manuscript, my document that I wrote up with them beforehand, and so they can basically sign off on it. And they're doing this to protect their investment, right? They're paying me to do their research, so they own the data, and they're not. I think they just want to make sure that I'm using it in an honest manner, basically, and they want to make sure that they get credit since they're paying for it. And so I think that most organizations that would create a restrictive license, they have good reasons for doing so, and they'll work with you, as an honest and legitimate scientist and researcher, as long as you, are willing to be flexible and follow, whatever sort of guidelines they've laid out.
Okay. Once the project is like done and you're not under their contract again, would like the same protocol be like still be used if you still wanted to do anything with your research? Or like
Yes,
their
because they
research?
still own it, right?
Okay.
Yeah, they own the rights to it. Yeah. But that's a good question. Yeah, the contract is like doesn't just because the funding has an end date, the project has an end date, doesn't necessarily mean that the ownership of it, transitions at the end of the contract, right?
Okay.
Just sending everyone a notice to come back. I always think that the sessions are going to go short and then I talk too much, but that's okay.
Well, it's interesting, so I feel like that's fine if you go over.
Yeah. The hope is that the discussions that people are having in the breakout rooms are at least interesting, so they don't mind.
Yeah.
Better than me rambling at them. All right, so I think we have most people back. In the interest of time, let's give one pro and one con. I guess the pro is a little bit easy. How about we give me 2 cons about licensing data sets? What did you talk about in your breakout rooms? Or maybe a very unique pro. I'll take that too. Okay, thank you, Christina. We have a unique pro, quality assurance. Do you want to elaborate on that a little bit? And I guess while you're elaborating, we have two cons: restriction to data to some degree. So you're kind of restricting access to it, and it could, restrict what you're able to do with it, which in turn might stifle innovation. So if we're preventing too many people from accessing the data, and kind of hiding it behind data usage licenses that don't allow others to use it, even with an attribution or non-commercially, it could prevent innovation. Absolutely. Okay, so it says, to be honest, I didn't really bring up the quality assurance point on the breakout room. But I think that's that it's to show that you could trust this data set since it's rigorously protected. Okay, I think it kind of makes sense. Like if you value this data set enough, in order to publish it and to put your name on it, put a license on it, it's likely that you put in the time and the effort to make sure that a quality data set was collected and processed. Otherwise, you wouldn't want to share it, out to the world, right? Because that would be dishonest and unhelpful to the research community. So Pooja says another con that relates to innovation could be heightened, maybe even toxic competitiveness and the silos of research spaces. So this is true. So I think she's saying that data usage licensing can kind of help ease competitiveness if we're all kind of if we create a culture of sharing our data, we can work together. That doesn't work if you're talking about it as a con. That relates to innovation. I guess you could think about a con as being if you are extremely competitive and wanting to keep back your data set, you would be very restrictive in your data usage license and then prevent others from accessing and using it. We have another from Brian that says cons, data sets can have cost or higher cost, and the research maybe not allow access to all information. And so that's related to the cost of access or creating and also maintaining the data set. There's definitely a cost, especially when you're talking about as technology improves and our ways that we can access and work with data change, we need to update our data to be compatible with any new technologies. And that does have a cost associated with it. A con could be that gathering data with proprietary information might get complex because you have to figure out how different companies allow you to reuse data. That's also true. You need to make sure that you're tracking the data usage license and keep and following it for any data that you do use. If you find data online, you can't just freely use it without looking at the data usage license. You need to be sure whether you're allowed to use it, especially if you're using it in a way that might alter the data in any way. Sometimes people will let you use it, but only in the native format that they provided to you. So you definitely need to keep track of the data usage licenses. And then last we have from Arushi, a con could be lack of funding to pay for licensed data, which in turn results in less funding or payment for the people who found that data in the first place. So yeah, so if you do license your data, but you also try to charge people for the data, which isn't much of an issue in the US when you're talking about federally collected data, or even state collected data. But if you do have a private company collecting data, or some foreign governments do put, at least in my personal experience, do put a price tag on some of the data that they collect. So it would definitely, you know, provide fewer resources for the people who found the data in the first place, and then also, you know, that might not be transferred on to them. Okay, so that was more discussion of cons, but thank you for the engagement, and I think you brought up some really good and interesting points. Okay, so we're just gonna briefly take a look at some data license types. These are not all the same as what was covered in the videos I shared. One of the things that I couldn't find was a specifically like a data publishing, data usage licensing video. Everything I could find was a software licensing videos. So that's what I shared. However, software licensing, software licenses, there's a lot of overlap between them and data usage licensing. And so I thought that it would be appropriate, but I did want to share the Creative Commons license. This is an extremely common and widely used license that is less used for software, but is very common for data. And then CC licenses, I just closed it, but there's tons of them available. And they have a Creative Commons license chooser. So depending on what you are trying to do with your data, what you want to do with your data, you can kind of go through this license chooser to help you pick the right Creative Commons license for your work. And so there's tons of different Creative Commons licenses, but they have different features like attribution, whether the people need to tell you whether or not people need to cite you, basically, whether or not you can use the data commercially, whether or not people can use your data to create derivative works or other work through different analyses based on this. Any sharing requirements, such as, you know, if you use this data, and if you use my data, do you have to share it with the same license, or can you apply your own new license to it? So maybe I create a data set and I have, you know, free open access, anybody can use it, no attribution required. But then, you know, Michael goes and uses it. Does he have to share this under the same license, or can he say, you know, you have to cite him and you can't create any derivative works on it, or something like that? So this is all about which license needs to be applied as this data is shared out. And then attribution details, that's probably just very similar if we were to click through all this as the original attribution. Maybe just a little bit more specificity. So this isn't the only data usage license selector out there, but this is the one developed for the Creative Commons license. Okay, so and then we also have the Open Data Commons license. So this is also a really popular set of licenses that also has some variety to them, but they similarly can help you publish your data. A proprietary license, which was, I think, mentioned in the video, but these are licenses where you want to basically maintain ownership of your data, and you're probably limiting access to it. You're probably charging a fee for people to use it, or maybe asking them to sign some sort of agreement in order for them to use it as well. And then the MIT license, which is becoming increasingly popular. I see it more and more and more, but it's a permissive license that lets you use, modify, and sell your code, but anything or data. But anything that you do with your data, you have to also apply the MIT license. So that's that sharing limitation we talked about with the Creative Commons license. You can do whatever you want with the data under the MIT license, but whatever you do with it, you have to maintain that MIT license on it. So if I do I have to, if I share it again, I modify it, I edit it, I make a derivative product, I have to maintain that MIT license when I again publish and or release that data. Okay, questions on the different types of data licenses? No? Okay. Let's go to, this is actually our last breakout room for the day. So let's just take 5 minutes here. We'll come back around 11:46, but let's discuss how are the standard data licenses similar and how are they different? And so think not only about what we talked about today, but about the videos that you watched before coming today, and then also considering the conditions and or limitations of your summer research, which type of licenses do you think would be most appropriate? So we'll come back at 11:47, I suppose, would be the best. Take 5 minutes. I'll give you a
Well-
minute. Oh, go ahead.
Would the similarity just fall kind of like the general like how they kind of like have like the same general basis of contributing like citing to like the original data?
I would say that's a very, very common feature of data usage licensing is that attribution. People want credit for what they've done, right? But that is not all Creative Commons licenses, or not all data usage licenses actually require that. So like the most basic, for example, Creative Commons license, I think it's a CC0 because there's no restrictions on it whatsoever. It's a completely free open data. You can do whatever you want with it and you don't have to tell anybody where it came from, where the data came from. But yes, I would say that it is very common to ask people to share or ask people to cite the original work, right? Because as scientists, we live and die by the credit that we get for the work we do.
Yeah.
Yeah. Any other thoughts on how they're similar or different?
Mm. I would say like just like the main like very like obvious difference would just be like the application, obviously, like the
Mm-hmm.
like the opacity that they would allow like access to the data.
Mm-hmm. Yeah, yeah. Were there any when we were talking about the, well, I guess if you were able to watch the videos and they were talking about the different restrictions on the data, or when we were looking at the Creative Commons page, were there any restrictions that surprised you?
Is it possible to like to go back to the slide?
Yes.
Sorry.
You're talking about this one?
Yes. Well, I would just say like more the derivative works.
Derivative, yeah.
Yes. Mainly just because like when you say that they do or don't have access to altering the data, like what exactly like does that mean?
Mm-hmm. Right. So it is, I agree with you, a little bit funny, like because I guess for me, what would be the point of accessing a data set if I wasn't going to do my own thing with it, right? And that's kind of where the derivative works comes into play.
Okay.
But I think that under derivative works, it's maybe more has something to do with publishing it, right? So if I do my own, I can take this data and I can do my research with it, but I can't apply a process to it and then publish it as a different product, basically, or a different data product, if that makes sense. So it's not limiting necessarily analysis, but I can't take this data, do something to it, and then publish it again under a different, even under the same license, because that would be then a derivative product.
Right.
Whereas I think you could still do analysis with it.
Okay.
Yeah. The one that always kind of surprised me was commercial use. Like I would feel, I wouldn't, I think, be frustrated to hear that, you know, my hard-earned data got used, I got commercialized, and I, you know, wasn't able to benefit or didn't learn about it or something like that, you know. So that one was always surprising to me, kind of commercial use.
Well, then, in that instance, like if someone does use it for commercial use, does the original creator like get like anything from that, or would that just like be like outlined in the license?
It would be outlined in the license. So if you pick
Okay.
as your license, you know, it can be used for commercial use, then you don't get anything. But if you say it can't be used for commercial use, then they're not allowed to use it for commercial use. And if they do, you could take legal action against them. Or if they wanted to use it for commercial use, they might come to you and ask for a special contract or something.
Okay.
Yeah. Okay. We should probably bring them back. All right, so anybody have anything interesting to share from their discussions in the breakout rooms on similarities and differences between the licenses, or perhaps what type of license is of most interest to you as a researcher? Understanding we did have a you know, fairly brief introduction to it, and at this stage of your research career, any data usage license you apply would definitely have to be consulted. You'd have to consult with your research advisor for, unless you were to go out and do some independent research, of course. So any interesting points from the discussions? No, okay. That's fine. I know it's about lunchtime, at least for me. So let's carry on. So Sydney says, expecting most of us will be using Creative Commons. I think that's probably an accurate guess. Creative Commons is extremely popular. And if it's used a lot in your discipline, if you see that used in your discipline, it's probably going to be the best choice for you. It's always a good idea to kind of align whatever you're doing with the common practice in your domain. Thank you, Sydney, for chiming in. Okay, so we just have a couple more slides here before I'll release you. But this is just talking about how to select the right license for your data. And the big point of this question is to don't just pick a license at random. You really want to think about which license would be more appropriate, and also understand where your data comes from, and understand whether you can actually publish it in a public repository, and if not, what sort of permissions might you need to get in order to do that. And that not only asks you to think about where the data came from, but what other conditions might be applied to that data through previous data licenses or any contracts under which that data was collected. And when you're thinking about this, think about any, ask yourself a bunch of questions to kind of figure out which would be most appropriate, such as, are you abiding by any contracts or terms of use, terms of service that would affect the publication of that data, either through the gathering of that data or the analysis of that data or the processing of that data, so on and so forth. Are you actually including data that is copyrighted under a different data usage license or restricted under a different license? Was your, what's this next one? Was your access to the original data you've processed under a contract that restricts or stipulates how you can actually create derivative products or release them? And does your university have any policies on how data products and other intellectual property content is released and licensed? Which would be something that you would probably have to be in consultation either with the legal team at your university or with your advisor. Okay, so for selecting a license for data release, I already kind of said this, but one of the best choices is to look at what your community does and see what's commonly used in your research community and follow along. And this one here, which is mentioned, is Creative Commons. Again, not because it's necessarily the best, but it is just the most popular, and so people are most comfortable with using it. You also want to make sure that you select a license that you understand. Make sure that you actually read the terms of the license and all of its limitations and restrictions and freedoms, so that you know what you're applying, right? Once you, like with the Creative Commons license, once you apply a license, it's there forever. You can't change it, you can't rescind it. It is what it is. So make sure that you actually understand what you're allowing with your license. And then the last is to declare the license, which you declare the license usually when you publish your data set in a repository. There's an option for applying the license to it. It's just one of the steps you do when you're registering and publishing your data set with the repository. And so as we saw, if we can go back to one of the first slides, you see here, it provides the data usage license right on the page where your data is published. So that is just part of the step of actually depositing your data. And that's the case not only with these public repositories like Zenodo, but also if your university has like a research commons or place for depositing research data conducted at that university. So, okay. Any questions? No? Okay. All right. Thanks, folks, so much for your time today. I know we went a little bit long, and I apologize for that, but hopefully it was an interesting and beneficial session, and that the discussions were refreshing, even if they did take a little bit longer time. I see we have a question from Henry. Or maybe that was a mistake. Oh, no worries, Henry. All right. So thanks so much for your attention. And I am going to be here all day, all morning, I guess, tomorrow with you when we talk about data processing, data analytics. So I'll see you tomorrow and have a great rest of your day. Bye, folks.
Thank you.
Thank you.
Thanks.